Dear students, in this video I explain problems on Bode plot. Already I explained in previous video, the Bode plot can be split into the number of parts. For example, g of s into h of s is equal to k by s into s plus 1 into s plus 2 like this, the given function. So this given function can be split into the three parts, k into 1 by s plus 1 into 1 by s plus 2. So draw the Bode plot for k, Bode plot for 1 by s plus 1, Bode plot for 1 by s plus 2, and combine these three, we can get the final Bode plot for the function k by s into s plus 1 into s plus 2. Like this, we can solve the given problems. So consider g of s into h of s is equal to 10 by s. This is the given function. Now I want to draw the Bode plot for this function. So now replace s by j omega. Therefore, g of j omega into h of j omega is equal to 10 by j omega. So this can be split into two parts. First one 10, second one 1 by s. So that g of s into h of s is equal to 10 into 1 by s. First draw the Bode plot for 10 and draw the 1 by s. Combined together, finally we can get the Bode plot for 10 by s. So first one Bode plot for 10. 10 means constant k. So that is factor 1. Already the factor 1, factor 2, factor 3 we are completed. Factor 1 is nothing but the given function having only the constant k. Factor 2 is nothing but the given function having poles at origin and zeros at origin. Factor 3 is nothing but simple pole or simple zero. That means pole other than origin, zero other than origin. So now first one is 10. So this is factor 1. So k, here the k value is 10. 10 is greater than 1. So that the magnitude plot for constant k is equal to 10 is nothing but 20 log k formula. So substitute k is equal to 10. Therefore 20 log 10, that is equal to plus 20 dB. So that the magnitude plot for k is equal to 10 is plus 20 dB constant. So that is the magnitude plot for 10. So and magnitude plot for 1 by s. So a pole at origin whose magnitude plot is a straight line of slope minus 20 dB for decay. So already this is factor 2. So factor 2 is nothing but so pole at origin, zeros at origin. If single pole at origin, the magnitude plot starts at so minus 20 dB for decays and finally reach to the 0 dB line at omega is equal to 1. So this is the magnitude plot for 10 and 1 by s. Combining of these two, we can get the magnitude plot of 10 by s. So therefore the magnitude plot for 10 by s is, so magnitude plot for 10 is 20 dB constant and magnitude plot for 1 by s is nothing but minus 20 dB for decay decreasing and reach to the 0 dB line at omega is equal to 1. Therefore at omega is equal to 1, 10 contributes 20 dB line, 20 dB gain and 1 by s contributes 0 dB, so that the resultant value is 20 dB. So this is the magnitude plot for 10 by s. Now the phase angle for 10 by s. So prepare the chart, individual chart for k and simple pole. Finally we can get the resultant. So this is the representation of so different omega values. So that is nothing but different frequencies. So angle contributes by k constant and angle contributes by single pole at origin. So the angle contributes by k, where k is nothing but 10. If k value is greater than 0, it will contribute 0 degrees. If k value is less than 0, it will contribute minus 180 degrees. That is factor 1. Already we know. So now the k value is 10, so that whatever it may be the frequency value, the phase contributes 0 degrees. So this is the phase angle due to the constant k. Now the phase angle due to the single pole at origin. So already we know from factor 2, if single pole at origin, it will contributes the phase of minus 90 degrees. So whatever it may be the frequency, it will gives or it will generates 90 minus 90 degrees phase. So the resultant phase is combining of these two. So already we know the Bode plot is nothing but multiplications are converted into the additions. So that adding these two, 0 minus 90 and so on, the resultant phase angle is minus 90 degrees constant. All values are minus 90 degrees, so that it is constant. So now finally we can draw the graph for Bode plot for 10 by S. So initially I draw the magnitude plot for constant K. So initially we can split this total graph into the decays and scales. So x-axis is nothing but log omega values, that means frequency values. So at omega is equal to 0.1, omega is equal to 1, omega is equal to 10, omega is equal to 100, like this. And this y-axis values are converted into the two parts. So this upper part is nothing but magnitudes, this below part is nothing but phase angle. So the total graph can be divided into two parts horizontally. So this part is nothing but magnitude plot, this part is nothing but phase plot. So now we can draw the magnitude plot. So consider R represents the 0 dB line. So this is the 0 dB line. So above 0 dB lines are positive magnitudes, plus 20, plus 40, like that. Below 0 dB lines are minus 20, minus 40, minus 60, like that. So this is the scale for gain. So now I want to draw the magnitude plot for 10 by S. Initially draw the 10, after that 1 by S. Finally adding of these two is nothing but 10 by S magnitude plot. So first draw the magnitude plot for constant K is equal to 10. So the constant K contributes 20 dB constant magnitude, so that the horizontal line drawn at 20 dB magnitude, so that this is 20 dB, so that the horizontal line drawn, so this line is nothing but 20 dB line. This is the magnitude plot for 20 log K, where K is equal to 10. And the magnitude plot for 1 by S. The magnitude plot for 1 by S is nothing but minus 20 dB decay, decreasing for decay, and omega is equal to 1, it will be reaches to the 0 dB line. So we want to draw the magnitude plot and it will be reaches to the 0 dB line at omega is equal to 1. So for decay it will be decreasing only 20 dB, so that it starts at plus 20. For decay it will be decreases minus 20, so that minus 20, plus 20, minus 20, 0 at omega is equal to 1. And again decreasing, again minus 20, 0, minus 20, minus 20, and again decreasing for next decay, for this decay it starts at minus 20 and add minus 20, it will be reaches to the minus 40, and next decay it will be starts at minus 40 and ends at minus 60, and so on. So this is the magnitude plot for 1 by S. Now we want to draw the resultant magnitude plot, that is 10 by S. So that is the final requirement. So at omega is equal to 0.1, the constant K contributes to 20 dB, and the pole at origin contributes 20 dB. 20 plus 20, 40. So this is the point. So indicate this point. Next one, at omega is equal to 1, so the constant K contributes again 20 dB, and 1 by S pole contributes 0 degrees. So 20 plus 0, 20. So that indicates the point here, 20 dB. And at omega is equal to 10, the constant K produces 20 dB, again constant, and 1 by S pole contributes minus 20 dB. So minus 20 plus 20. So that is 0. So indicates this 0 dB line. So adding these 3 points, so plus 40, plus 20, 0, and again minus 20, minus 40, like this. So this is the final resultant magnitude plot for 10 by S. This is the magnitude plot. Next, draw the phase plot. So below this horizontal line we can consider the phase angles. So reference phase angle 0 degrees line. So above this 0 degrees line positive angles will be there, below 0 degrees line negative values will be there. So 0 degrees, minus 90, minus 180, like that. So already we completed the calculations. Whatever it may be the frequency, the phase angle, resultant phase angle is minus 90 degrees. So draw the straight line at minus 90 degrees. This is the resultant phase angle for 10 by S. So this is the resultant magnitude plot for 10 by S. This is the resultant phase plot for 10 by S. This is the total Bode plot for the given function g of s into h of s is equal to 10 by S.